now we need to design counter circuits. And so this first one is supposed to count from 0 to 14 and then go back to 0. So we only need 4 bits. So enable 1, 2, 3, Q0, Q1, Q2, Q3, and a load, and a clock. Okay, so we are going to want to load 0. And we want it to detect a 14. And to detect a 14, when we detect a 14, we want it to go back to 0. So let's look at what 14 looks like. So 14, that's 8 plus 4 plus 2. This is 0. This is the 1's place, the 2's place, the 4's place, the 8's place. 8 plus 4 plus 2 is 14. So we want to detect when we have 1's in those 3 places. And when we have 1's in those 3 places, that will detect 14, and it'll reload and it'll go back to 0. We don't have to include the 0 here because 14 is going to be the first time that you have 1's in all 3 of those places. If you look at all of the numbers before that, none of them before that have 1's in those 3 places. And so, I mean, you could write them out. Just let's start with 10. So here's 10. Here's 11. Here's 12. Here's 13. And here's 14. So 14 is the first number that has all 1's right there. Alright, so now we want to go from 3 to 12 and then back to 3. I don't know if I put a 1 in my enable. Okay, so our numbers were 3 and 12. Let's look at what those look like. So Q3, Q2, Q1, Q0. 3 looks like this. And 13 is 8 plus 5, so that's 8 plus 4 plus 1, so that's 13. So we want to load 1, 1 for Q1 and Q0, and 0, 0, so that'll load a 3. We want to detect Q3, Q2, and Q0 being 1. So Q3, Q2, Q0. And we want to load that. Now let's see, is that the first time that those 3 will all be 1? So this is 13. Let's start with 10. So 10 looks like that. So that's 10. And then 11. And then 12. And then 13. So 13 is the first time that all 3 of those are 0. So that should do it. Except, of course, now that I'm looking, I read the problem wrong. So the problem said the sequence was only supposed to go to 12, not 13. So Okay, so the sequence actually, I was supposed to go from 3 to 12. So 3 to 12. So almost the same. So 3, we're still going to load those numbers. This time we are looking for 12. And that will be when these two, oh, I have my D's and Q's backwards. That will be when Q2 and Q3 are both 1. So that would be that one. Okay, so now we have 5 to 15, and then to 0, and then to 5. So we start over at 5. So that's a little different. So we're going 5, 6, 7, 15, 0, 1, 2, 3, oh no, 0, 1, and then 5. So helpful to read the problems. So we get to 1, and then we reload 5. So 5 is what we load, and 1 is what we detect. Okay, so 5 looks like this. And 1 looks like this. So we're going to have to be careful here. We can't just detect a 1, because a lot of the numbers that we're going to count are going to have that 1 there before we actually get to 1. We will need to load a 5, so we'll need to load 1, 0, 1, 0. And then we want to detect when we get a 1. Well, Q0 is going to be 1 a lot of times before we actually get to 1. So if we start with 5, then we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0, 1. And this is the one we want to detect. So we can't just look for a 1, because we've got a lot of these that have 1s. We can't just look for 0, 1, because that shows up in multiple places. Can't just look for 0, 0, 1, 0, 0, 1, because that shows up here. So we actually have to detect 3 zeros and a 1. So our AND gate needs to have Q0 should be 1, and these others need to be zeros. Alright, and then our last problem, no, last two problems. So we're counting from 16 to 64 and back to 16. So 16 to 64, and then back to 16. So we need more than a 4-bit counter for that. So let's just make an 8-bit counter. So that's an 8-bit counter. We want to load a 16. So if you think about binary numbers, that's the 1's place, the 2's place, the 4's place, 8, 16, 32, 64, 128. So a 16 looks like this. That's Q0, that's Q7. So we want to load a 1, so Q6, Q5, Q4. We want to load a 1 into D4 and zeros everywhere else. And we want to count until we get to 64. And you won't get a 1 in the 64's place until you get to 64. So all you have to do is detect that Q6. So that would be a counter that counts from 16 to 64. Now, if we wanted to do this by putting two counters together, so we would have one 4-bit counter and another 4-bit counter. So the top one, you'd have the enable is 1. A load there. And Q0, Q1, Q2, Q3. And enable here. D0, D1, D2, D3. Q0, Q1, Q2, Q3, and load. Now remember, the way that you make an 8-bit counter out of two 4-bit counters is you detect when all 4 of these are 1. When all 4 of these are 1, then that means it's time to enable the second counter. So that enables a second counter. Now we are loading 16, so that's going to be 0, 0, 0, 0, and 1, 0, 0, 0, because these are going to be like positions 4, 5, 6, 7, and we are detecting 64. And so when we detect 64, we just need to check. So 64, 0, 0, 0, 0, that's 8, 16, 32, 64. So that's 64, that's right here. So that's the one that we want to check. And when that one becomes a 1, we want to load both of these. Okay, and our last one is a counter that goes from 128 to 7 and then back to 128. So load 128, detect 7. Okay, so 128 has a 1 there and zeros everywhere else. So I just made an 8-bit counter here. So for my load, I'll load a 1 here and zeros everywhere else. And then, so when it loads, it'll load a 128. And then it'll start counting. 129, 130, so forth. And it'll get down to 255. And after 255, it'll wrap back around to 0. And then a few more clock cycles, it will get to 7. And that's going to be where we want it to stop. But we want it to stop here. So we could say, you might think, well, we just need to detect when these 3 are 1s. Well, it is true, those 3 do need to be 1s. Okay, but that's not going to be good enough because there are other places where those 3 are 1s, like for instance right here. But one thing you will notice is that up until here, if we started at 128, we always had a 1 in this first position. So all the first half of more than half, the first from 128 to 255, all of those have a 1 in that position. And then we get to 0 and we have a 0. And then as we count up to 7, this number is the first place that has 3 1s here and a 0 here. So I could then have this be my load condition. I could also, if I wanted to, load that, put that all of these had to be zeros. I just was lazy and didn't want to draw all those lines.